In this video, we are going to go in depth into what is the difference between speed and velocity. In the previous lesson, we learned that distance is a scalar quantity, whereas displacement is a vector quantity. A scalar quantity has only magnitude, whereas a vector quantity has both magnitude and direction. In this lesson, we are going to learn another set of scalar and vector quantities, that is, speed versus velocity. Very often in the exam, you will be asked what is the difference between speed and velocity. Remember that you must state that speed is a scalar quantity, whereas velocity is a vector quantity. Now, what is velocity? In essence, velocity is speed in a given direction. Speed measures how fast an object moves, and it tells you the distance moved per unit time. Velocity tells you the distance moved per unit time as well as the direction of motion. To understand the difference between speed and velocity, let's look at this example. In this slide, we define the westward direction as negative and the eastward direction as positive. If a car moves to the west and travels 60 kilometers in an hour, its speed is 60 kilometers per hour. Its velocity is negative 60 kilometers per hour. Now, if another car travels eastward at 60 kilometers per hour, the speed of this car is 60 kilometers per hour and his velocity is positive 60 kilometers per hour. Now let's look at the formula of speed. Since speed is distance traveled divided by time, speed in a specified direction would be distance traveled in a specified direction divided by time. But we know that speed in a specified direction is velocity. And in lesson 2, we have learned that distance traveled in a specified direction is displacement. We can derive the formula that velocity is change in displacement divided by time taken. Since the SI unit of displacement is meters and the SI unit of time is seconds, the SI unit of velocity is therefore meters per second, which is the same as SI unit for speed. Hence, by definition, velocity is the change in displacement per unit time. To understand this better, we shall go back to the earlier example of the girl running on the track that is 200 meters in distance and making a displacement of 50 meters. The distance traveled as she ran on the track is 200 meters. If she takes 25 seconds to travel that distance, her speed is therefore 200 meters divided by 25 seconds, which equals to 8 meters per second. However, with a displacement of 50 meters, her velocity is 50 meters divided by 25 seconds, which is 2 meters per second. From this example, we can see clearly that speed measures the change in distance per unit time, whereas velocity measures the change in displacement per unit time. If the speed of an object changes, its velocity changes. However, note that when the speed remains constant, its velocity may not be constant if there is a change in direction. Back to the example of the cyclist which travels eastward. He traveled a distance of 22 meters. His displacement is also 22 meters. If the time taken is 10 seconds, his speed is 2.2 meters per second. His velocity is also 2.2 meters per second. Now, bear in mind this speed of 2.2 meters per second, and we shall look at a second scenario where he travels at the same speed but has a change in direction. Now the cyclist travels eastward 16 meters, make a U-turn and stop at the 3 meters mark. His total distance is 33 meters, but the displacement is minus 1 meter. If the total time taken is 15 seconds, his speed remains at 2.2 meters per second, same as before. However, his velocity is minus 0.067 meters per second. Having learned what is velocity, we are now ready to move to the next lesson about changes in velocity.